Hi, welcome to MathCub. In this particular video, we will be discussing one problem from NCERT Mathematics Class Plus 2 textbook from the chapter of Applications of Derivative related with the concept of maxima and minima. The question is, prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8 by 27 of the sphere volume of the sphere. Now they have given a sphere with the radius r. We are inscribing a cone. That means we are inscribing the cone which is of the largest possibility. That means that we are inscribing the largest cone. So now we are comparing the volume of the largest cone with that of the volume of the sphere. We need to establish that the volume of the largest cone will be equal to the 8 by 27 times as that of the volume of the sphere. So when you consider here, we can understand that the radius of this sphere, radius of the sphere is equal to r. The center of the sphere is at O. Now when you're considering this particular cone, we know that for a cone the base will be a circle. That particular circle will be having a radius, correct? That means if you write the radius of the cone, the radius of the cone is nothing but this point is C. That means this is equal to BC. Done. Then when you consider OC is basically like the distance from the center of the sphere to the center of the base of the cone. That is, we just assume it as x. Okay, we just assume it as x. So when you consider the triangle OBC, when you apply Pythagoras theorem, we can write it as OB square equal to OC square plus BC square, OB equal to R square equal to OC equal to x square plus BC square, x square plus BC square. Done. So here BC is not known to us. That means the base radius of the cone is not known to us. So we can write it as BC square equal to R square minus x square. That is BC equal to square root of R square minus x square. BC equal to square root of R square minus x square. So when you're considering the height of the cone, the height of the cone is nothing but equal to AC. AC is nothing but equal to OA plus OC. What is OA? OA is the radius of the sphere R plus x. Okay, done. R plus x. So when you consider the volume of the sphere, the volume of the sphere is nothing but equal to 4 by 3 pi r cube. 4 by 3 pi r cube. We need to establish that the volume of the cone is equal to the 8 by 27 times as that of the volume of the sphere. That is equal to 4 by 3 times the pi r cube. That is equal to 8 into 4, that is equal to 32 divided by 81 pi r cube. So what we need to establish is that volume of the cone is nothing but equal to 32 by 81 as that of the pi r cube. This is what we need to establish. Clear? So we need to try whether we will be able to establish this or not. We know that the volume of the cone is equal to 1 by 3 into base area into height. So that is equal to 1 by 3 into base area. Base is a circle. So the area will be pi r square, pi into what is the base radius? The base radius is equal to the square root of r square minus x square. So when you take the square, it will become square root of r square minus x square the whole square, pi r square, into height. What is the height? Height is nothing but equal to h plus x. So not h, r plus x. How you got? I will explain once again. For example, this is the base circle. The area of this particular base circle is equal to pi BC square. What is BC? Square root of r square minus x square into height. Height is nothing but OA. OA equal to r plus x. So when you open up, you will get 1 by 3 into pi into square root of r square minus x square into square, that will become r square minus x square into r square minus x square into r plus x into r plus x. If you open up the bracket, you will get 1 by 3 pi into r square into r plus x minus x square into r plus x. If you again open up the bracket, you will get 1 by 3 pi into r cube plus r square x minus rx square minus x cube, rx square minus x cube. So basically this is nothing but equal to volume. So we need to check when the volume will become maximum. According to applications of derivative, if you want to check maximum or minimum, what we can do? We can check for the first derivative. That is dv divided by dx. Why x? X is the variable here. X is the thing which is varying here. For example, if you have a sphere like this, if you are inscribing like this, automatically what will vary? X will be less. If you are inscribing like this, x will be more. So the x is the variable here. Correct. That is why we are checking it up. With respect to x, what will vary? The base radius also varies, but we express base radius in terms of x. Okay, so there is no issue. So when you take the first derivative, it will become 1 by 3 pi into, you need to check the derivative of this. We know that the derivative of r cube with respect to x, the radius of the sphere is not varying with respect to the radius of the sphere. So radius of the sphere is not varying with respect to the base radius of the cone. That is why the derivative of r cube will be equal to 0 plus derivative of r square x will be equal to, r square is the constant. Therefore dx of dx equal to 1. So you will get r square minus r into derivative of x square will be equal to 2x minus derivative of x cube will be equal to 3x square. So what you will get? You will get it as pi by 3 into r square minus 2rx minus 3x square. According to the first derivative test of the in derivative, if you want to find out the point of minima or maxima, at that particular point, the dv by dx will become equal to 0. That means first derivative will become equal to 0. That means if dv by dx equal to 0 means pi by 3 into r square minus 2rx minus 3x square will be equal to 0. That means r square minus 2rx minus 3x square equal to 0. Here, if you want to simplify it, what we can do? If you take this particular rx, this r square x can be written as, 2rx can be written as minus 3rx plus rx minus 3x square equal to 0. Why do we did this? We can take the common. How? Because there is a 3 factor is there. When there is a 3 factor is there, we are just splitting the middle term. When you are splitting the middle term, we can get like this. So if you take r common here, you will get r minus 3x. If you take x common here, you will get r minus 3. So we were able to take the common. So that means if you take r minus 3x common, you will get into r plus x equal to 0. That means either r minus 3x will be equal to 0 or r plus x will be equal to 0. That means r will be equal to 3x. That is x will be equal to r by 3. X is equal to r by 3. Here r plus x equal to 0. That means r is equal to minus x. But we know that the negative value cannot be taken because they are measurements. So only the possibility is x will be equal to r by 3. Okay, that we got. Now we need to check whether the point x is equal to r by 3 is a point of maximum or minima. For that particular purpose, we need to take the second derivative. That means we need to take d square v by dx square. If d square v by dx square is less than 0, that is a point of maximum. If it is greater than 0, that is a point of minimum. So we have, what is dv by dx? dv by dx is equal to pi by 3 into r square minus 2rx minus 3x square. You need to take the second derivative. So it will become pi by 3 into derivative of r square with respect to x will become 0 minus derivative of minus 2rx with respect to x, you will get minus 2r. Derivative of 3x square with respect to x, you will get minus 6x. Then minus 6x. Okay, done. So what you will get? D square v by dx square is equal to, if you take negative out, you will get minus pi by 3 into 2r plus 6x. 2r plus 6x. So if you substitute the value of x here, what you will get? Minus pi by 3 into 2r plus x is equal to r by 3. So 6 into r by 3. These two get cancelled. You will get 2 here. So what you will get? Minus pi by 3 into 2r plus 2r, that is equal to 4r, that is equal to minus 4 pi r by 3. So what you got? We got a negative value. Since we got a negative value, it clearly shows that point corresponding to the point of maximum. Okay, clear. So that we understood. Now we need to find out whether that particular volume is going to be 8 by 27 times. How we can establish that? At x is equal to r by 3, we know that the volume of the cone is equal to 1 by 3 into pi into r square minus x square into r plus x. We got x equal to r by 3. So if you substitute 1 by 3 into pi into r square minus, so x square will be equal to r square divided by 9. So r square divided by 9 into r plus r by 3. So this is equal to 1 by 3 into pi into, so r square minus r square by 9 equal to 9r square minus r square by 9 if you do cross multiplication into 3r plus r divided by 3. So this is equal to 1 by 3 into pi into 9r square minus r square equal to 8r square divided by 9 into 3r plus r equal to 4r divided by 3. So if you multiply, what you will get? 8 into 4, 32. R square into r, that is equal to r cube. So 32 r cube divided by 9 into 3, 27. 27 into 3, 81. So the volume of the cone, the volume of the largest cone that can be inscribed will be equal to 32 pi r cube by 81. This is what we need to check. Why? Because we established that 8 by 27 times asset of the volume of the sphere equal to 32 by 81. So we got the same value. So this is the way in which we can solve this particular kind of question. Hope the explanation is clear. If you need any further clarification, do let me know in the comment section. Opinion about the class can also be commented. As a token of gratitude, please like to this particular video, share with your friends, subscribe to our channel. Keep watching, keep learning. Thanks for watching. Bye.